Hi, so in this video we're going to be talking about how we generate new chunks in Xenoplanet. So you can see as I move around the game world, new chunks aren't being generated full rows at a time. They're being generated one chunk at a time. And this is to prevent lag spikes. If we generated an entire row of chunks at once, it would pause all the other calculations going on the CPU and just finish generating that row of chunks, causing a huge lag spike before coming back to other calculations. And actually, we split up the generation of all chunk related stuff into multiple frames. So the trees that are being placed on the chunks are being placed over multiple frames, the grass is being placed over multiple frames, and even the height maps of these chunks are being created over multiple frames, all so that you don't notice lag spikes when playing the game. Here, if I just maximize the game, you can see there aren't really any lag spikes, even when new trees and chunks are being placed in the game. Now I'm just going to show you how that's done in the code. So it mainly relies on the coroutine function in Unity. So here, this is the coroutine that generates the height maps for the world and all the other noise maps that we use. And you can see for each row of noise, we start a timer at the start of the function. And for each row of noise that we generate, we check if we've been spending more than 3 milliseconds generating rows of noise. If we have, we break the coroutine and allow other stuff to be calculated on the processor before coming back and loading more rows. So we can load multiple rows at a time, but if we've spent more than 3 milliseconds loading rows, we just say, hey, go deal with the rest of the stuff happening in this frame processor and come back to this so that you don't cause a lag spike. And we do the same thing with all this chunk related stuff, but I'm just going to show you how we do that with the actual placement of the chunks. So this loads an entire row of chunks, but you can see it doesn't do it all at once. Every time we load a chunk, we do the same thing and give the processor a break, allow it to do other calculations, and then it will come back to this and place another chunk. We do the same thing with the grass and the tree placement, but I'm not going to show that all off this video. Anyway, you can see that by breaking up those calculations over multiple frames, it creates a very smooth gameplay. And you can even see the trees being placed over multiple frames in the background there. Anyway, thank you.